Alright, let's talk about interior angles of polygons. Just as a reminder, what's a polygon? What are some common polygon names? Think about them. Well, here are some: square, rectangle, trapezoid, parallelogram, rhombus, triangle, hexagon, pentagon, heptagon or septagon, octagon, nonagon, decagon, and dodecagon. Hopefully when you're hearing those vocabulary words, you're starting to think of attributes that they have in common or that they do not have in common, and then how they relate to each other. Also notice that I put not a circle. You need to remember that circles are not polygons. If you're unsure about that, you want to review what are the criteria to be a polygon, and that will help. So before we investigate interior angles, we better remind ourselves what is an interior angle and what's an exterior angle. Well, an interior angle is the inner of the two angles formed where two sides of a polygon come together. So right here, this 120-degree angle inside this hexagon is an interior angle, whereas an exterior angle is the angle between any side of a shape and the line extended from a side. So you could see if we continued this side of the hexagon into a line, we would see an exterior angle of 60 degrees here. It's nice for us to remember that these two angles, this interior and exterior angle, are supplementary since they sum to 180 degrees. Let's review a little bit more. What's a diagonal of a polygon? Does a triangle have a diagonal? Why or why not? You might want to try drawing a triangle and then seeing if you could draw a diagonal. Well, a polygonal diagonal is the line segment connecting two non-adjacent polygon vertices of a polygon. So here's an example of diagonals of a quadrilateral. So if I went from this vertice to this vertice, you notice those are not adjacent. Adjacent vertices are ones that are right next to each other. So I've drawn two diagonals in this quadrilateral. Did you try it with a triangle? A triangle does not have a diagonal since all vertices are adjacent to each other.